Good morning, my dear students. In this video presentation, we'll discuss some more problems meant for class 12 of CBSE. The first problem meant for today goes like this. I'll write the question directly, I'll move on to the problem directly. Evaluate integral dx by sine power 4x plus cos power 4x. This is the question given to you. Let me just start with the answer. This is the given one. I will just take out cos power 4x is common. Therefore, I will end up with sin power 4x by cos power 4x plus 1. I will take this to the numerator. I will write it as secant power 4x by tan power 4x plus 1. Can be written as secant square x into secant square x dx divided by 1 plus tan power 4x. Can be written as 1 plus tan square x d of tan x divided by 1 plus tan power 4x. This can be written as integral 1 plus t square dt by t power 4 plus 1, where my t is nothing but tan x. Here I will just take t square as common, both numerator and denominator, divided by t square into t square plus 1 by t square. Therefore, here t square will get cancelled. This can be written as d of t minus 1 by t plus t minus 1 by t the whole square plus 2. You can just verify. Just see here, d of t is 1, d of minus 1 by t is plus 1 by t square. Okay, I am not well. Sorry if there is any disturbance in the middle. Therefore, I can make it as a perfect square in terms of t minus 1 by t in the denominator. Therefore, this can be written as du by u square plus root 2 the whole square, where my u is t minus 1 by t. Therefore, this is nothing but 1 by root 2 tan inverse u by root 2, which is 1 by root 2 tan inverse t minus 1 by t by root 2 plus c, which is 1 by root 2 tan inverse tan square x minus 1 by root 2 tan x plus c by replacing t by tan x. By replacing t by tan x. I repeat the whole process once again. Just see here. Integral dx by sine power 4x is cos power 4x. I'll just take cos power 4x as common. Just multiply inside, you'll be able to see the difference, whether it's right or wrong, you'll be able to find out. Cos power 4x gets cancelled here. Taking this to the numerator, it becomes secant power 4x. Secant power 4x can be written as secant square x and secant square x dx. Can be written as 1 plus tan square x d of tan x by 1 plus tan power 4x, because d of tan x is nothing but secant square x dx. I'll replace this tan x by t, 1 plus t square dt by t power 4 plus 1, t is tan x. Take t square as common for both numerator and denominator. T square into 1 by t square plus 1 by t square plus 1 by t square in the denominator. T square gets cancelled anyway. Numerator can be written as d of t minus 1 by t, and denominator can be written as a perfect square in terms of t minus 1 by t. Just check, t square plus 1 by t square minus 2 plus 2 will get cancelled. Replace this by u, du by u square plus root 2 the whole square, where u is t minus 1 by t. Therefore, it will be 1 by root 2 tan inverse u by root 2. 1 by root 2 tan inverse t minus 1 by t by root 2 plus c. After taking LCM, replace t by tan x. Therefore, 1 by root 2 tan inverse tan square x minus by root 2 tan x plus c. Tan x is outside the root. Only root is there only for 2, not for tan x. Therefore, I repeat, 1 by root 2 tan inverse tan square minus 1 by root 2 tan x plus c will be the final answer. It is not at all difficult to follow. You need to follow each and every step systematically. Then this problem is not at all difficult. Just listen carefully. Okay, the next problem again is also on integration. Let me just see what it is exactly. Next problem goes like this. Evaluate integral, it is x square dx by x power 4 plus 2x square minus 15. Now while you think of the denominator, I'll be able to split the middle term. Can be written as x power 4 plus 5x square minus 3x square minus 15. X square into x square plus 5 minus 3 into x square plus 5. You can just verify. X square into x square is x power 4. X square into 5 is 5x square. Minus 3 into x minus 3x square. Minus 3 into plus 5 minus 15. Now for this can be written as x square plus 5 into x square minus 3. Yeah, it's correct. Therefore, for the whole integral, put x square equal to t only for partial fraction. The real idea is, after identifying the values of constants a and b, the integration has to be done with respect to x. That is the meaning of only for partial fraction. Let me just proceed. Let t divided by t plus 5 into t minus 3 to b is equal to a by t plus 5 plus b by t minus 3. It is the application of partial fractions. After taking LCM and cancelling out the denominator, I end up with t is equal to a into t minus 3 plus b into t plus 5. Substituting t is equal to minus 5 in 1, we get, what do I get? Minus 5 is equal to minus 8a plus 0, which implies a becomes plus 5 by 8. A becomes plus 5 by 8. Okay. Now substituting t is equal to 3 in 1, we get 3 is equal to 0 plus 8b, which implies b becomes 3 by 8. Therefore, the whole integral now becomes x square dx by x square plus 5 into x square minus 3. My a value is 5 by 8. 5 by 8 integral dx by, my denominator here is x square plus 5, minus plus 3 by 8 integral dx by x square minus 3. Therefore, I can very well write this as dx by x square plus root 5 the whole square plus 3 by 8 integral dx by x square minus root 3 the whole square. Therefore, this will become 5 by 8 into 1 by root 5 tan inverse x by root 5 plus 3 by 8 into 1 by 2 root 3 log mod x minus root 3 by x plus root 3 plus c. Therefore, this will ultimately becomes root 5 by 8 tan inverse x by root 5 plus root 3 by 16 log mod x minus root 3 by x plus root 3 plus c. That will be the final answer. That will be the final answer. Let me just check whether it's right or wrong. What I have done in my notebook. Yeah, it's correct. Here I'll be able to split the middle term, the denominator I can factorize. I can write 2x square as 5x square minus 3x square. I'll take x square as common from the first two terms and minus 3 as common from the third and fourth terms. Now for x square plus 5, x square minus 3 is nothing but this fourth degree polynomial. X power 4 plus 5x square minus 3x plus 2x square, 5 into minus 3 is minus 15. Now put x square equal to only for partial fraction. Or partial fractions, plural also you can write, it doesn't matter. Now for like t by t plus 5 into t minus 3 is equal to a by t plus 5 plus b by t minus 3. After taking LCM and cancelling the denominator, I'll get t is equal to a into t minus 3 plus b into t plus 5. Name it as equation 1. Put t is equal to minus 5. Minus 5 is equal to minus 8a plus 0. Minus 5 plus 5 is 0. 0 into b is 0. A becomes 5 by 8. Put t is equal to 3. 3 is equal to 0 plus 8b. b becomes 3 by 8. Now the integral becomes 5 by 8 times integral dx by, this is my right in terms of x and then integrate. That's the real meaning of put x square equal to t only for partial fraction. Everywhere you have x square involved. The application is put x square equal to t only for partial fractions. Now for 5 by 8 integral dx by x square plus 5 plus 3 by 8 integral dx by x square minus 3. Replace this 5 by root 5 the whole square. Replace this 3 by root 3 the whole square. It's the form dx by x square plus a square. 1 by 8 tan inverse x by a is the formula. 1 by root 5 tan inverse x by root 5. This is the form dx by x square minus a square. 1 by 2a log mod x minus a by x plus a. Now for 1 by 2 root 3 log mod x minus root 3 by x plus root 3 plus c. Here a is root 5, here a is root 3. Here root 5 gets cancelled. Root 5 8 tan inverse x by root 5. Here root 3 gets cancelled. Root 3 by 16 log mod x minus root 3 by x plus root 3 is the final answer. As I already told you, I am trying to minimize any video for maximum of 15 minutes. The rest I will continue in the next video. As I used to tell you, if there is any correction, I will just add up at the end. I don't think there is any correction, and just go through. Thank you for patient watching.